Hi, my name is Nur Ifaoni binti Muhammad. My matric number is 203573.
My name is Azmira binti Rosli and my matric number is 203572.
Hi, my name is Siti Nurhanis binti Nur Halim and my matrix number is 200977.
The Higgs boson is an elementary particle in the standard model of particle physics produced by the quantum excitation of the Higgs field, one of the fields in physics theory. It is named after physicist Peter Higgs. In 1964, along with 5 other scientists, proposed the Higgs mechanism to explain why some particles have mass. Particles acquire mass in several ways, but a full explanation for all particles had been extremely difficult. This mechanism required that a spinless particle known as a boson should exist with properties described by the Higgs mechanism theory. This particle was called Higgs boson. A subatomic particle with the expected properties was described in 2012 by the ATLAS and CMS experiment at the Large Hadron Collider (LHC) at CERN near Geneva, Switzerland. The new particle was subsequently confirmed to match the expected properties of a Higgs boson. In quantum mechanics, boson is a particle that follows Bose-Einstein statistics. Bosons make up one of the two classes of particles, the other being fermions. The Higgs field is thought to give mass to fundamental subatomic particles like the quarks and leptons that make up ordinary matter. The Higgs bosons are wiggled in the field like the bump we see when we twitch a rope. The Higgs field does not technically give other particle mass. More precisely, the particle is a quantized manifestation of a field, the Higgs field, that generates mass through its interaction with other particles. But why couldn't just be assumed as a given? The answer always goes back to previous work in quantum field theory. Quantum fields are similar to more familiar fields like electric and magnetic fields, but quantum fields contain excited states that been observed as particles. These fields can be divided into matter field whose particles are electrons and quarks, and force field whose particles are photons and gluons. In the late 1940s, theorists showed that a quantum field theory of photons and electrons could successfully explain electromagnetic interaction at high energy.
Now I'm going to talk about the central problems of Fields boson. There was not yet any direct evidence that the Higgs field existed, but even without proof of the field, the accuracy of its predictions led scientists to believe the theory might be true. Now, Higgs field existence. For many decades, scientists had no way to determine whether the Higgs field existed, but the technology needed for its detection did not exist at that time. If the Higgs field did exist, then it would be unlike any other non-fundamental field, but it also was possible that these key ideas, or even the entire standard model, were somehow incorrect. The hypothesis Higgs mechanism made several accurate predictions. One crucial prediction was that a matching particle, called the Higgs boson, should also be exist. Proving the existence of the Higgs boson could prove whether the Higgs field existed and therefore finally prove whether the Standard Model's explanation was correct. Therefore, there was an extensive search for the Higgs boson as, as a way to prove the Higgs field itself existed. The existence of the Higgs field became the last unverified part of the Standard Model of particle physics, and for several decades was considered the central problem in particle physics.
Now we are going to talk about the search and discovery of field bosons. In 1960s, physicists modeled the behavior of particles using equation rooted in quantum physics. Based on the equation, if the particle were massless, the equation will work perfectly. But the physicists knew that the particle have mass, and when they modified the equation to take this fact into account, the equation did not work anymore as it became complex and inconsistent. They then used the idea put forward by Higgs by considering the particle operating within an environment in which the space is uniformly filled with an invisible substance, which is now called the Higgs field. Physicists who study Higgs' proposal then realized that Higgs' idea was genius. In Higgs' scheme, the fundamental equation can retain their form because the environment has provided the particle masses. By the mid-80s, the physics community had mostly bought the idea that there was a Higgs field permeating space. However, these were only proven by mathematical equation and it was not yet established experimentally. This is where the Large Hadron Collider comes in. The Large Hadron Collider, LHC, is nearly 17 miles long circular tunnel that acts as a racetrack for smashing particles of matter. It is surrounded by 9,000 superconducting magnets and is storing 2 tons of protons cycling around the tunnel in both directions, which the magnet accelerate to just shy of the speed of light. To find the evidence of Higgs field, the colliding particles should be able to jiggle the field, just like 2 colliding submarines would jiggle the water around them. And at times, the jiggling should be just right to flick off a speck of the field, which would appear as the long-sought Higgs particle. The calculation shows that the Higgs particle would be unstable, disintegrating into the other particles in a very small fraction of seconds. Scientists armed with powerful computers would search for the Higgs fingerprint, a pattern of decay products dictated by the equation within the colliding particles. Early 2012, 2 independent teams of researchers had announced a strong indication that the Higgs particle had been found. The evidence that the Higgs particle had been detected was strong enough to cross the threshold of discovery. And now we are going to talk about the implications of this discovery. As we know, there are invisible inhabitants of the space, but none of them are permanent. In the regard, the Higgs field is fundamentally different. As far as we can tell, the Higgs field are indelibly imprinted into the spatial fabric. The Higgs particle represents a new form of matter. In the early 20th century, physicists realized that particles should have their spin. However, unlike any other particles, the equation describing Higgs particle showed that it should have no spin at all, and the data from the LHC have confirmed this.
The conclusions of Field's boson. After discovery, we began to study the properties of the newly discovered particle to understand if it was the standard model Higgs boson or something else. In fact, we initially called it a Higgs-like boson, as we did not want to claim it was the Higgs boson until we were certain. We don't only do tests to verify that the properties of the Higgs boson agree with those predicted by the Standard Model. We specifically look for properties that would provide evidence for new physics. We also look for decades to combinations to combinations of particles forbidden in the standard model. So far, none of these searches have found anything unexpected, but that doesn't mean that we were going to stop looking anytime soon. Thank you.